Now let's just move on further towards the theorem number 3rd, which says that the sum of any two sides of a triangle is greater than the third side. So here we are totally talking about the inequalities rather than the equality. So here we are saying that if we are just taking the sum of any two sides of a particular triangle, then it is always greater than the third side. So let us suppose if I'm just taking a triangle over here and I'm just writing the given conditions that we have. Let us suppose this is my triangle ABC that I'm taking. So let us suppose if I'm just starting with the given condition. Given is nothing but a triangle ABC, a triangle ABC in which what we have to prove, that AB plus AC is greater than BC. So let us suppose if I'm just taking these two sides, means AB and AC, whose sum should be greater than BC. You can take any two sides and you can also prove that any two sides is greater than the sum of the third side, means the sum of the two sides is always greater than the third side. So you can take any particular side. I'm just taking these two sides which should be greater than this side, and I'm just doing a little bit of construction over here. So what is the construction? So let us suppose if I am drawing this particular triangle again in a smaller manner. Let us suppose if I'm just drawing this triangle again in a smaller manner, such that I am extending this BA towards any particular point D. I'm extending this BA towards a particular point D, and I'm just joining this DC. So we are just saying extend BA to D such that AD is equal to AC, and further join DC. So I have just done a little bit of construction over here in such a manner that this side should be equal to this side. Now furthermore, let's just start the proof of this particular theorem. So we are starting the proof as let us suppose if I'm just talking about the triangle ADC. So since you can say in the triangle ADC, we know that AD is equal to AC. It implies that the angle ACD is equal to the angle ADC. Why so? Because the angles that are opposite to equal sides, are always equal. Hence, these two angles are actually equal to each other. This angle and this angle is equal to each other. Let us suppose if I'm calling it as angle 1, I'm calling it as angle 2, I'm calling it as nothing but angle 3. If I'm calling them as angle 1, angle 2 and angle 3. Now, furthermore, if I'm just moving on further, so we know that angle 1 is equal to the angle 2. We know about this particular concept. Okay. Further, let's just move on towards the BCD angle. Let us suppose if I'm just talking about the angle BCD. So what can we say about this particular angle, which is BCD? Since you can see that BCD is actually nothing but a combination of these two angles, which is nothing but angle 3 plus of angle 2. So we can write BCD as nothing but angle 3 plus angle 2, and from the equation number 1, we know that BCD angle is nothing but can also be written as angle 3 plus angle 1. From equation number 1, we can say this thing, that we can use angle 2 as is equal to angle 1 over here. Now furthermore, what can we conclude from here? We can conclude from here that angle BCD means this total angle is equal to angle 3 plus angle 1. Means this angle is a combination of these two angles, which implies definitely that the angle BCD is greater than the angle 1. Definitely we can say about this particular fact that if we have BCD, which is nothing but angle 3 plus angle 1, then we can definitely say that BCD is nothing but greater than the angle 1. And what can we say about this BCD? The side which is opposite to BCD is nothing but AD. The side which is nothing but opposite to this BCD is nothing but BD. It implies BD is greater than the side which is opposite to the angle 1. The side which is opposite to the angle 1 is BC. It implies that BD is nothing but greater than BC. We can say about this thing from the fact that in any triangle, the sides opposite to the larger or the greater angle is longer. We can say about this thing. So hence it implies that BD is nothing but greater than BC using that particular theorem. If BD is greater than BC, so we can write BD as nothing but BA plus AD. Obviously BD is nothing but a sum of these two, that is BA plus of AD, which is nothing but greater than BC, Hence it definitely implies that if BA plus AD we have, is nothing but greater than BC. So in place of AD we can write AC. So let us suppose if I am rewriting it as nothing but in place of BA I am just using AB, plus in place of AD we can write AC is nothing but greater than BC, since we know that AD is nothing but is equal to AC. So this is the thing that we have to prove over here, that the sum of the two sides of any particular triangle is always greater than the third side. So you can see AB, we are getting AB plus AC, which is nothing but greater than BC, So this is the thing that we have to prove over here. And similarly you can prove that if we are just taking a sum of AB plus BC, it should comes out to be greater than AC. Or if I'll take the sum of AC plus of BC, or CA plus of BC, then it should be greater than the AB. So in the simultaneous manner you can also prove this thing as well. So this is all about this theorem.